Page 2, number 6. Write the equation in slope-intercept form of the perpendicular bisector of a segment with endpoints at 2, 5, and 4, 9. Okay, this is still going to be a money pays bills question. It's just a little bit trickier. So you look at your ask. It says write the equation in slope-intercept form. So that should make you think right away we're going to be doing some money pays bills stuff. But it's going to get a little trickier. So let me start setting up my graphic organizer, and then we'll talk. So y equals mx plus b, m equals space for my point, and we need to solve for b. Now let's talk. They want the perpendicular bisector. So perpendicular, we're thinking opposite reciprocal slopes, and bisecting a line segment that they gave us by just giving us the two endpoints for that line segment. Segment means a line segment. So let's kind of visualize what they're talking about here, okay? We're going to do a little sketch. So they have some line segment. It has endpoints of 2, 5, 4, 9. And they want us to bisect it, which means it needs to cross at the midpoint. So I'm approximating, maybe the midpoint's around here. So bisect means you have to cross at the midpoint. And it needs to be perpendicular, so it should have an opposite reciprocal slope, probably something that looks like this. So our end goal is to find the equation of this red line that's going to bisect the green line segment at its midpoint and also be perpendicular. That's our goal. I'm going to erase this, and I'm going to throw this onto my graph and talk specifically as to, well, what's the midpoint and what is the slope that should be from my line. So let me erase all of this. Okay, so let's go to our graph. Let's go ahead and plot those 2 points that they gave us. So we have 2, 5 and 4, 9. Okay, I'm going to connect those two so I could see my line segment. So here's my line segment. Now remember, it needs to bisect it, so it should probably pass through the midpoint, which looks like it's right around here. And it needs to be perpendicular, so it looks like it's going to go like that. I'm going to erase those two things because I need to talk specifically. What is the midpoint? What is the slope? Let's start with slope. Okay, so let's count the slope. We're going to do rise over run. So I always start with the point on the left. You're going to count up and to the right. So we're going up 4, and then we're going to go to the right 2. Both of these are positive movements. So it's going to be a positive 4 over a positive 2, which means when you simplify, it's just 2, or 2 over 1. Now that's the slope of this green line segment. Our slope needs to be perpendicular. So perpendicular to 2 is going to be a negative because that one's a positive, and you have to flip the fraction. So remember, 2 is the same thing as 2 over 1. So flipping it, we'd have 1 over 2, negative 1/2. This is our slope. Okay, so that's exactly what we want to put in to our graphic organizer because it's perpendicular to this green line segment. So let's go to our graphic organizer. Let's put in our negative 1/2. So negative 1/2. Next, we need to solve for our point that's going to be on our line. And remember, when it says bisector of a line segment, you're thinking midpoint. So just focus on that midpoint. Now, I'm going to put an M capital outside of my point to remind myself I need to find the midpoint. So go back to your graph. Most of us can visualize where this midpoint is going to be. But if we want to be specific, we want to be accurate, we're going to go ahead and use our midpoint formula. So our midpoint formula, which you've written down for a previous question and you've put it down on your reference sheet on the back, you're going to add your x's and divide by 2. Add your y's, divide by 2. So for midpoint, our x's are 2 and 4. Divide that by 2. Our y values are 5 plus 9. Divide that by 2. 2 plus 4 is 6, so 6 divided by 2, we get 3. 5 plus 9 is 14. 14 divided by 2 is 7. 3, 7 is our midpoint. Let's go to our graph to see if that makes sense. 3, 7 is right around here. Yeah, that's what we thought it was going to be. Makes sense. I like it. Let's go back to our graphic organizer. We're going to plug in that 3, 7 into our graphic organizer, and we're going to solve for this y-intercept. Three, 7. Plugging everything in. Our y is 7. Our slope is negative 1/2. Our x value is 3. Plus b. Starting to solve. 7 equals. Now we have negative 1/2 times 3. Again, I'm going to set up my multiplication because I don't have a calculator. Put the 3 over 1 and multiply across. Negative 1 times 3 is negative 3. 2 over 1 is 2. Now, if you know what that is, when you actually divide this, you should know that it's a negative 1.5. So now I'm going to put this in. This is negative 1.5, although I could have kept it as an improper fraction, plus b. Last step, I want to get b by itself, so I'm going to add 1.5 to both sides. Those are going to cancel. 7 plus 1.5 is 8.5. That's going to be your b value. Go ahead and put that into your graphic organizer, 8.5. And now we're ready to write our answer down. Our answer is going to be using this negative 1/2, using this b value. We're going to get y equals negative 1/2 x, don't forget the x, plus 8.5, which is where it should cross the y-axis. Let's go to our graph. Let's see if this makes sense. Okay, I'm going to use the concept of slope. I'm going to plot my line, and I'm going to see, does it look like it crosses at 8.5 on the y-axis? So let's go to our graph. Okay, so I'm going to use the concept of slope to figure out where my points should be. Right now I have this midpoint, which I know is on my line. I'm going to use negative 1/2 to figure out where the other point should be. So negative 1/2 means I go down 1 if I put the negative in the numerator, and I go right 2. So down 1, right 2, I'm going to put a point. Down 1, right 2. Now I want to go in the other direction because I want to see where it crosses the y-axis. So if I put the negative in the denominator, in the bottom, then my positive 1 says go up 1, and the 2 being negative says go to the left 2, because left is a negative movement. So up 1, left 2, up 1, left 2, and I'm going to connect these points. And yeah, it looks like I'm crossing right between 8 and 9. So that makes sense. It would be about 8.5. Write your answer down. Let's go on to the next question. Question 7. Identify each pair of lines as parallel, perpendicular, or neither. Now I'm going to warn you, I'm going to be doing a lot of writing, and it's probably going to have to require you to grab a separate piece of paper to follow all the work, because we've got a lot of choices here and a lot of equations that we have to work with. Now, going back to the question, identify each pair of lines as parallel, perpendicular, or neither. So our answers are either going to be parallel, perpendicular, or neither. Now, how do you determine if things are parallel, perpendicular, or neither? We've been doing it this whole time. Parallel means things are going to have the same slope. So you care about slope. Perpendicular means they're going to have opposite reciprocal slopes. And then the last one, neither, well, that would be any other combo. So if they're not the same and they're not opposite reciprocals, then, well, they're neither. Okay? So the key here is we care about slope. Slope, 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 slope. Now let's go through each choice and let's go ahead and figure out if they're parallel, perpendicular, or neither. Let me clear off my board. Okay, starting with A. I'm going to zoom in. We want to make sure before we get started that each one of these lines is in y equals format. If y is not alone, then it's not as easy to tell what your slope is. So before we go ahead and figure out, oh, this is the slope, we have to first make sure it's in y equals form. Now for A, we're comparing these two lines. Look at your first line, y equals 2x plus 1. We see that y is by itself, which means the number in front of x, the coefficient to x, is your slope. Here is our slope. It's 2. Now for the second equation, it's 4y equals negative 2x minus 5. We don't know our slope yet because y is not by itself. So what we have to do is get y alone. So we're going to have to divide everything by 4, every term, in order to get y by itself. So we get y equals, now be careful here, negative 2 divided by 4, you can simplify that. You can divide top and bottom by 2. So it's going to be negative 1/2 x, negative 5 over 4. Yep, let's bring it down. Now, as a word of advice, we never care about the b values. We never care when it comes to comparing if things are parallel, perpendicular, or neither. All we care about is slope. Let's take a look at the slopes. Positive 2, negative 1/2. Well, they're opposite signs, and they're also reciprocals of each other because 2 is the same thing as 2 over 1. So if they're opposite reciprocals, that means your answer is perpendicular. Let's go on to B. Now these are going to require a lot more writing. Okay, B. 6y equals 9x plus 7. Well, not in y equals form. Let's divide out the 6. So we have y equals 9 and 6 can be divided by 3. So let's simplify. It's 3 over 2x plus 7 over 6. Next one, 2y equals 3x plus 4. Well, let's divide out that 2. So y equals 3 over 2x plus 2. All right, since they're both in y equals form, all we care about is slope. So here we go, 3 over 2 and 3 over 2. Oh, they're the same slope. The answer is they are parallel. They're going to cross the graph at different y-intercepts, but they're going to look like they're both following the same direction. And C. Okay, well, C is going to require the most amount of work. So let's take a look. I'm going to move to the side of my whiteboard so that I can have room to rewrite these equations and solve them. So the first one for C is 5x minus 7y equals 12. So I want to get y by itself. We start by getting rid of whatever is being added or subtracted. So we need to move that 5x first. So we're going to subtract 5x from both sides. This cancels. So now we have negative 7y equals negative 5x plus 12. Always put the larger degree first. By larger degree, it means if you have a variable, you're going to list that first, and then you're going to list the whole number at the end. Almost done. Our y is still not alone. So now we need to divide every term by negative 7 so that we can break up this union between the negative 7 and the y, which is multiplication. How do you get rid of multiplication? Well, you divide. The negative 7's cancel, so now we have y equals the negative 5 and the negative 7. The negatives cancel. 5 over 7. Don't be afraid of weird fractions or mixed numbers. It's good when it comes to slope. Bring the x down, and now 12 divided by negative 7. The positive and negative makes a negative, and let's keep this as an improper fraction. Because at the end of the day, we don't care about the b value when we're trying to figure out parallel, perpendicular, or neither. Okay, so the second equation, 10x plus 14y equals 9. You should try this one by yourselves, but if you're really stuck, go ahead and follow along with me. We're going to get rid of the negative, or rather the 10x first, by subtracting 10x. Okay. Bring down the 14y. Negative 10x and 9 can't combine, so we're going to write the negative 10x first, plus 9. And now we need to divide everything by 14 to get the y by itself. So we have y equals negative 10 and 14. You're going to get a negative. 10 and 14 can be divided by 2. That's our greatest common factor. So I'm going to simplify to negative 5 over 7 x plus 9 over 14. Now remember what we care about when we care about figuring out if it's parallel, perpendicular, or neither. All we care about is slope. So we have 5 over 7 and negative 5 over 7. It's kind of tricky. The answer is neither. These two lines are simply going to cross. Maybe they look like this. They're going to cross, but they're not going to be perpendicular. The reason is one's positive, one's negative. However, for them to be perpendicular, well, the fraction would have to be flipped. And it's not. They're both 5 over 7. And they're not parallel because, well, one of them's negative and the other one's not. So this is just going to be neither. They're just going to cross. Let's go on to the last part of this question. X equals 1, y equals negative 5. Now, if you recall the question number 5 where we talked about hoi vux, these are unique situations. They don't follow your normal y equals mx plus b form. X equals lines, if you remember, hoi vux. X equals lines are vertical, meaning they go up and down. So imagine x equals 1 is an up and down vertical line. Y equals negative 5, well, y equals lines are horizontal. So we're going to put a horizontal line, and then we ask ourselves, a vertical up and down line, a horizontal left and right line, are those parallel? No. They're definitely going to cross, and when they cross, they're going to be perpendicular. So the answer to this question is going to be perpendicular. These are one of our most famous lines. If you know what the x and y axis looks like, those are horizontal and vertical lines that are perpendicular. So this last example, whenever you see an x equals line and a y equals line, the answer is they are always, always, always perpendicular. Next question. Number 8. Find the length of the line segment connecting points M, 0, 0, and T, negative 3, 4. Find the length. This is your ask. When you're finding the length of the line segment, any line segment, you have two choices. One, you could do distance formula. 2, you can use Pythagorean Theorem. Now, when we say distance formula, you have to memorize that. You're not going to get that. I'm going to write it down, and you could choose to use it, although I favor the Pythagorean Theorem. So let's look at the distance formula. The distance formula, let me zoom in a little bit. is going to be D equals big square root sign x2 minus x1 squared plus y2 minus y1 squared. In my classes, I like to do the Pythagorean Theorem, which is a squared plus b squared equals c squared. It's the same thing as the distance formula, but it allows us to do it visually. So if you wanted to do it with the Pythagorean Theorem, which is the way that I'm going to show you, you need a graph. So you'll notice that on my paper, I added a graph. So let's go to that graph and let's go ahead and work it out. So first we need to plot our 2 points. We have 0, 0 for M. Oh, that's a little too thick of a line. Let's change that up. And then the second point is at -3, 4. Okay. Let's label that one T. And let's go ahead and connect M and T. Okay, so we're trying to figure out the length of this line segment. The way that you're going to do it if you're using Pythagorean Theorem is you're going to create a right triangle, because Pythagorean Theorem is only used with right triangles. So to create the right triangle, we can have it go to the right, ooh, too far, to the right and down, or we can go down and to the right. But your goal is to create that right triangle. So I'm going to leave it like this, and I'm going to count the boxes, because my goal is to do a squared plus b squared equals c squared. A and b are the two sides that make up the little right angle for your right triangle, and c is always the slanted side, the side that's your hypotenuse, the one across from the right angle. So when you're trying to figure out the length of a line segment, C is always going to be what you're trying to solve for. Now, let's count. 1, 2, 3 boxes for vertically. 1, 2, 3 boxes. Oh, I made a mistake. 1, 2, 3, 4 boxes vertically. 1, 2, 3 boxes horizontally. It doesn't matter which one you call A and which one you call B. I just decided to make the vertical part A. Now we'll do 4 squared plus 3 squared equals c squared. 4 squared is 16. 3 squared is 9 equals c squared. 16 plus 9 is 25. That is your c squared. You don't want c squared, you just want c. You want the length of the side, not the length of the side squared. So to get rid of the square, you're going to have to square root both sides. When you square root a square, those are inverse operations, so they cancel. Square root of 25 is actually a perfect whole number. It's 5. That's your C. So the length of this yellow highlighted line segment is 5 units. It could be centimeters, it could be inches. It depends on what the question is telling you. But the length is 5. If this, for example, this is not what's happening here, but for example, if it was square root of 34 that you get at the end to equal C, 34 is not your length. It's the square root of 34. So I'm going to go to my calculator here, and I'm going to type in 34 square root, and you'll see it's about 5.83, yada, yada, yada. So in the future, you're going to have to take the square root, and it's not going to be a pretty number. So you will need your calculator. But because in this question, you had a perfect square, you did not need a calculator. Your answer, your final answer, is 5 units. 5 units. And I like to use this glittery type of cool font here. Okay? 5 units. Let's go on to the next question. Number 9. This is our first calculator question. Pause the video, read the question for yourself once, and then come back and we'll go through it. Okay. Anna is watching fireworks launch on the beach. While that's great information, thank you so much, we do not need it. So with our annotation skills, we're going to cross this off because that's not very important for us. She is sitting on the sand 250 feet from the firework launch point. Now we have a value here. This is important. So we're going to underline the fact that she is sitting 250 feet from the firework launch point. Now think about where fireworks launch from. They launch from the ground. So if she's sitting on the beach, then horizontally away from her is 250 feet, the launch point. So I'm going to put a little sketch here, and my artistry is just, it's impeccable. So here is Anna. She's sitting on the beach. The launch point is, let's say, right here. This distance is 250 feet, our horizontal distance along the ground. Now let's keep going. Anna tilts her head at an angle of elevation of 37 degrees to see the first set of fireworks explode. So the fireworks are going to go straight up. When they explode, here's my wonderful visual. She would have had to tilt her head up at an angle of elevation. That means you're going up from the horizontal line. So going up, she's tilting her head 37 degrees. Okay. Now, 5 seconds later, the next set of fireworks exploded at an angle of elevation of 64 degrees. So they set up some more fireworks, and now the next set, well, let's say it's exploding up here somewhere. Still going to be launched up from the original launch point on the ground. But now she's tilting her head at 64 degree angle of elevation. Now for the first 37 degrees, when you have an angle of elevation, you have to be thinking trigonometry. Now that 37 degrees is going to form a hypotenuse with that first set of fireworks. The second set of fireworks is going to form another hypotenuse. But that second set of fireworks is at an angle of elevation of 64 degrees in total from the ground. Not just added right here, but from the ground. So 64 degrees. Now, let's get to the question. To the nearest tenth, okay, so they're telling us how to round at the end. To the nearest tenth of a foot, what is the vertical distance between the two fireworks, where the two fireworks exploded? So what is the vertical distance? This is their ask. Between the two fireworks. Okay, well, one firework explosion was here. The second one is here. Vertically, they're looking for this distance right here between them. Well, with trig, we first need to make sure you have right triangles, and we do. The launch going upwards and the sand along the ground is going to create your right angle. What you should notice is there's actually two overlapping right triangles. So what you're going to have to do is break out these two right triangles and take a look at what we have. Let's break out that bottom red right triangle that had the 37 degree angle of elevation. So I'm going to break this out. We have 250 feet along the ground. I'm going to zoom in a little bit further so it's easier to draw. So we have 250 feet. We have our right angle. Anna's right here. Okay. Erase a couple of things. Just want to erase just the A. And if you know why, it's going to be because we use A, O, and H when we do trig. Okay, I'm going to put the 37 degrees right here. Okay, so we want the vertical distance between the two fireworks. However, what I want to do first is maybe figure out, well, what's just the vertical distance from the launch point to the first set of fireworks? I'm going to call that X. Okay. Now the second triangle, I'm going to break that one out. Actually, I should probably make it a lot taller. The angle of elevation was 64 degrees and still 250 feet along the horizontal. Okay, so this vertical height, well, that's going to be this whole distance from the launch point all the way up. I'm going to call that distance y. Now, if I have x and I have y, if I subtract them, I take the difference, kind of like segment addition postulate. If I take the difference, I'm going to be left with just this highlighted yellow section. So here's my game plan. Let's solve for x. Let's solve for x. Let's solve for y. And then if we subtract, we'll figure out what's left right here. So that's our game plan. When we do trig, and this is a situation for trig, we want to make sure we're labeling opposite, adjacent, and hypotenuse. Now, we start at our reference angle. We're going to use the one that they gave us, although we could use an angle at the top if we wanted to. But we're going to use the one that they gave us, 37. We start by labeling our opposite, which is what we're looking for, that vertical height. We have our hypotenuse, which is always across from the right angle. And then we have our adjacent side, which is the one touching the 37 that's still a leg to the right triangle. So the same thing with the other one. Circle the 64, label the opposite. The hypotenuse is the slanted one across from the right angle, and then the adjacent side is touching the 64 degrees. All right, so let's do some trig. The reason I'm going to do trig is because I have one angle and one side. There's nothing else we can do to figure out the length of any line segment if we only have one angle and one side. Only thing you can do is trig. Now, you have the opposite, which is what you're looking for, and the adjacent, which is a value that you have. H has nothing to do with this whatsoever, so I'm going to ignore H. O and A is TOA, tan. So I'm going to do the tangent function here to figure out the length of x. I'm going to do tan of 37 equals the opposite side x over the adjacent side 250. We're going to multiply both sides by 250 in order to get x by itself. This is all calculator work now. When you do this in the calculator, you have to be very careful because the one that you get in your hand is different than the one that you're going to see on the screen on the EOC. The way that we type this in is we always type the angle before we hit sine, cosine, or tangent. So I'm going to do 37, then I'm going to hit tan, and then I'm going to multiply it by 250. So watch what I do in the calculator. 37 tan, which is approximately 0.7535. It's going to show you what the tangent of 37 is. Then you're going to multiply that by 250. Hit equals 188.3885. I'm going to go out 4 decimal places because I want to be safe. I know at the end I have to round to the nearest tenth, but in the meantime, let me go out 4 decimal places. So I'm going to say x equals 188.388 and 5, because after the 5 is a 1. So that is the vertical distance to the first launch of fireworks. We're going to repeat this again to get the vertical distance to the second launch of fireworks. Go back to our visual. So here we have again opposite, adjacent, hypotenuse. The hypotenuse has nothing to do with this. We're not trying to find it. We don't have a value for it, so we don't need it. O and A, again, you're going to use TOA, tan. So I'm going to go ahead and set up my tan function. Tan of my angle, which now is 64, not 37 anymore, equals my opposite side y over my adjacent side of 250. Multiply both sides by 250. These will cancel. And now calculator work. Remember, 64 first, then the tan, then multiply by 250. So I'm clearing this out. 64 tan, it's about 2.05, that's the tangent of 64, times 250. 512 and then some decimal. So let's go ahead and write down y equals, I'm going to go out 4, 512.5759. Okay, so the 9's going to round up to 10, which means if I go out 4 decimal places, I have to round as 5760. Okay, let's look at our visual. So our vertical height all the way to the top was approximately 512, approximately. That's not exact. It's from here. Our first launch was about 188 feet in the air. So we want to figure out what's left over here, so we're going to subtract. Okay, so in your calculator, you're going to go to your calculator, you're going to click 512.5760 minus 188 point, let me change that, 188.3885 equals, and it's about 324 feet. They want us to round to the nearest tenth, so we're going to say 324.2. So going back to my work, my final answer is going to be 324.2 feet. That's the distance between the first and the second launch. Next question. Number 10. Remember, you want to read the question by yourself first and then come back and listen how we break it down. The Firefighter Academy is running drills with cadets. Okay, unnecessary information. The fire captain is watching cadets climb a tall vertical ladder. The first cadet he sees is at the 164 feet mark on the ladder. So here's our first value. Now, think about what's happening. We have a fire captain, and he's watching cadets climb a vertical ladder. It's not slanted. It's going straight up. So let's draw a visual here. I'm going to draw my awesome stick figure. He's standing on the ground, so that's horizontal. And then we have this ladder. Okay, so the first cadet he sees is at the 164-foot mark. Okay, so let's draw a cadet. Let's imagine the 164-foot mark is, well, let's say he did a great job. It's at the top. 164 feet high. Okay, so that's this vertical distance. It's 164 feet. So he's here, and the cadet sees him. Or actually, the fire captain sees him. So the fire captain is standing on the ground 35 feet from the base of the ladder. 35 feet from the base of the ladder. So he's standing here. The base of the ladder is here. 35 feet away means it's the vertical distance, the horizontal distance here of 35 feet. Okay. Next, what is the angle of elevation that the fire captain must tilt his head to see the cadet? Okay, so this is my ask. What is the angle of elevation? Trig. Angle of elevation, trig, 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 trig. So angle of elevation means you're going up from the horizontal line. So horizontally, that's our distance from the base of the ladder. So when this cadet looks up, he's tilting his head at an angle of elevation. This is x. We don't know what it is. It's x degrees. Now, when you're trying to figure out an angle and you're using trig, what becomes different is you use the second function. So things that look like sine to the -1, tan to the -1, cosine to the -1 in the calculator. You're doing inverse trig. But you're still setting things up the normal way. You have to figure out opposite, adjacent, and hypotenuse. So our angle is here at x. Opposite that is 164 feet. The hypotenuse is this slanted length, and then the 35 is your adjacent. We don't need the hypotenuse. It didn't give us a value, and we're not trying to solve for it. So let's look at what we have. 164 feet as the opposite, 35 feet as your adjacent. O and A, well, that's TOA again. Now, when we set this up, we're going to do tan of x, because now your angle's missing, so we just have to call it x, equals opposite over adjacent, the 164 feet over the 35 feet. Now, this is going to end up being calculator work. What you do is you take your x value and you say, to get it, I'm going to have to do tan to the -1 power of 164 over 35. Now this 164 over 35, that gives you a decimal, and your calculator knows what degree is associated with that decimal and tan. So I'm going to go to my calculator. I'm going to type in 164 divided by 35. So it's approximately 4.68, yada, yada, yada. So going back to my work here, x equals the inverse tan to the -1, of 4.6857, so on and so forth. Okay? Now go back to your calculator, let it do all the work for you. So back to the calculator. We have to activate the second tan button. To do that, you're going to click second on the ones that you're holding in your hand. It should be a green button that says second. But on my calculator, it's this up arrow. So I hit that. I see the tan -1. So I hit the tan -1. And it spits out an answer for me. 77.952, whatever degrees. That's the angle. So I'm going to go back to my work. I'm going to write down x equals approximately 77.5929. Well, it's going to round up to 30, but let's go back to how we have to round. It says to the nearest degree. That means a whole number. You don't want to have a decimal. If it says to the nearest degree, the nearest foot, the nearest grain of rice, the nearest box, whatever they're saying, they want a whole number. So no decimal. So taking a look at this, I'm going to try and round. I want the nearest whole number. So either I keep it at 7 or I round up to 8. The 5 next door says I should round up. So round the 7 up to 8. So our degree is 78 degrees. Okay, we're done on page 2.